Hi AP Calculus students, it's Miss Culver. We are working on 3 problems from the Chapter 1 test review on limits, which also includes section 3.5. A warning before you watch this video: if you have not thoroughly tried every single problem on the test review on your own, then checked it with a key, and then retried those problems, then you should not be watching this video yet. I will be working on number 18A, 12C, and free response question number 1. If you first watch this video for these 3 problems without actually having tried it, I think it might create a false sense that you could do it on your own. So you have to try these problems on your own. If you have not done that first, you need to stop the video now and come back to it. All right, it doesn't mean we won't go over other problems. I just felt that these problems might be the ones that students would have the most questions on. So I'm going to 18A first. So I have that review in front of me. You have your review in front of you also. And here is 18A. It says if f of x is sine of x minus 1 over cosine squared x, then the limit as x approaches pi over 2 of f of x is equivalent to which of the following? So notice what's happening is if you try to check the limit using direct substitution, that when you put pi over 2 in the denominator, cosine of pi over 2 is 0. So what they're asking you to do when you look at the functions that are available to you is see if you can write this function in a simpler way to evaluate or still not evaluate the limit if you can't use direct substitution. But they're just asking you to write a simpler function is what they want from you. Okay, there's a few ways to go. I'm hoping that you tried this on your own. I'm hoping maybe you tried to break sine over cosine squared up into one expression and 1 over cosine squared. Notice 1 over cosine squared is secant squared, but when you take a look at the 4 possible answers, we're not seeing that there. Also notice there's a sine over cosine here, which is a tangent, with a 1 over cosine left, which is a secant. The 4th answer, we do see a tangent and a secant, but I'm not really seeing something that exactly matches what I just said by trying to break this up. So again, let me say that real quick. I'm seeing something like this. Notice I broke up the common denominator into 2 pieces. And so what I'm seeing here is tangent times a secant here minus a secant squared. And that is not one of the answers. And so that was a really nice try. So let's try something else. What I'm going to shoot for here is a Pythagorean identity. It's really important that you know the 3 Pythagorean identities. So what I'm going to use is sine squared x plus cosine squared x equals 1. Or said another way, if I subtract a sine squared from both sides, I get that sine squared equals, sorry about that. I wanted to subtract a sine squared from both sides because that's legal to do. Cosine squared equals 1 minus sine squared. If I'm making any little mistakes, I am sorry. It is a Sunday night at 9 o'clock, and I just thought that I would get this done after a long day. So I'm going to use this expression here to help myself. So here we go. I'm going to keep the denominator the same. In the numerator, where I see a cosine squared, I'm going to replace it with a 1 minus sine squared. Now what I see in the denominator is this is the difference of squares. So numerator is the same, and in the denominator, I see 1 minus sine times 1 plus sine. Notice that the 1 minus sine looks an awful lot like the numerator, except for that the signs, positive or negative, are backwards. I would love for the sign to be negative, it's positive in the numerator. I would love for the 1 to be positive, it's negative in the numerator. That is no problem. I can factor out a -1 from the numerator, and that leaves me with a +1 minus sine of x. Again, take a quick moment and check to see that my numerator is exactly the same as the numerator I'm pointing at right now. But now I see a factor in the denominator that I can cancel out. 1 minus sine of x, and my simpler function is -1 over 1 plus sine of x. And that's how they got the answer that they did on 18A. Let's look at 12C. So flip to that. I'm going to flip to that also. Let me see what I thought that you must have needed there. Oh, okay, absolutely. Okay, the population on an island is modeled by, that's 6,000, divided by 40 plus 60 times e to the -0.03 times the time, where the time is greater than 0. And they are asking you, what is the limit of this function as t approaches infinity? Students will often have a hard time with bases of e, and so we are going to practice this, and we are going to use direct substitution. I am going to put in infinity right for this t here and see if I can evaluate this limit. So I have 6,000 over 40 plus 60, and that's e to the -0.03 times infinity. Okay, notice that, let's look right here, a -0.03 times infinity is a negative infinity. Okay, so all I'm doing is changing the e to the -infinity. There we go. Now it's kind of hard for students to work with negative infinity, but I know how to make that a positive infinity. So numerator is the same, 40 plus 60, and instead of multiplying 60 by e to the -infinity, I'm going to move the e to the -infinity to a denominator and make it positive, and now I can understand it a little bit better. 60 divided by e to the infinity is 0, and I'm left with 600 divided by 40, or I'm left with 600 divided by 4, or I'm left with 300 divided by 2, which is 150, and that's how they got the answer that they did. Let's look at response question number 1. There's a few parts to it. Let's take a look. You are looking at it with me, so I don't have to rewrite everything. It says that they are giving the function ax squared plus bx plus 2. By the way, this is definitely a problem like would be on the AP exam. It says that a and b are constants, and the graph of f has a horizontal asymptote at y equals 3. That means the limit as x approaches infinity of the function equals 3. And f has a removable discontinuity at x equals 2. Removable discontinuity at x equals 2. Okay, let's find out what all this means. Show that a equals 6 and b equals -13. They actually do this on the AP exam where they give you the answer and ask you to show that it's true. Okay, let's take a look first. In green, here is a. They want us to show a equals 6 and b equals -13. Okay, how do I know that a equals 6? I get that from the fact that the horizontal asymptote is y equals 3. So the limit as x approaches infinity is 3. Take a look here. this was rational functions. And notice that the highest degree in the numerator and denominator is the same, okay? That means that when I try to do direct substitution of infinity, that because the degrees are the same, either using logic or factoring out the x squared, that a is equal to the, that a is equal to, is what I meant to say, is that the leading coefficients, a divided by 2, right, must be 3, right? So a divided by 2 has to equal the horizontal asymptote of 3. So let's look at that again. Again, when we are trying the limit as x approaches infinity, this was section 3.5. We factored out the highest degree in x squared from the numerator and denominator, or by logic, we see the highest degrees are the same. So that means that the horizontal asymptote, or the limit, would be the division of the leading coefficients. A divided by 2 must equal the horizontal asymptote of 3. And so you can see now why A is equal to 6. Okay, so the next thing we're going to do is, now that we know that A is 6, is let's put it in and let's see if we can answer B. So A is 6. Okay, now how do we know that B is a negative 13? Here's how we know. I am first going to factor the denominator. I'm going to factor out a 2. And that would leave me x squared minus 4, so that's x minus 2, x plus 2. Now, notice what I'm going to use is that there's a removable discontinuity at x equals 2, okay? Notice right here in the denominator, if I try to put a 2 into x minus 2, right, that I get a 0 in the denominator. But they're saying that this factor, x minus 2, is removable. That means x minus 2 must be in the numerator, so it cancels out the x minus 2 in the denominator. Here we go. So in other words, they gave me a hint with the removable discontinuity at x equals 2 that this x minus 2 in the denominator also has an x minus 2 in the numerator and cancels out. Okay, let's see. Well, x minus 2 times something is 6x squared plus bx plus 2. Let's see what that would be. It would have to be a 6x, right? And then to get a minus 2, that would have to be a minus 1. Let's see if that works. That would be 6x squared. Let's see, minus 1, minus 12, and a plus 2. There we go. And then, so that is how I ensure that the first term is correct in the numerator and the last term. Okay? That ensures that the 2 is a removable discontinuity. But take a look here. Let's circle this in blue. When we multiply out this numerator, we get 6x squared minus x minus 12x minus 13x and plus 2. There we go, showing that B is equal to a negative 13. Excellent. Let's see what they ask us next. Next they ask us to make f continuous at x equals 2, f of 2 should be defined as what value, and justify your answer. So let's take a look. So that would mean to make f continuous, at x equals 2, f should be defined as f of 2 should be what? Okay, let's take a look. We have crossed out the x minus 2's, right? And we are left with the simpler function, 6x minus 1 over 2x plus 2. There's our simpler function, right? And let's pop in, they want f of 2, so let's put that in. Let's put in the 2 for x and see what value we should have to make f continuous at x equals 2. So when we put in a 2 here, we get 12 minus 1 is 11. And when we put a 2 into the denominator, that's 2 plus 2 is 4, times 2 is 8, 11 eighths. So this is the answer for B. To make f continuous at x equals 2, right? It's not right here. That's a non-removable discontinuity. So they're saying, hey, to make it continuous, if we want to put a point where x equals 2 on the function to make it continuous, where should that y be? And it's 11 eighths. Okay, let's see if we can answer the final question, C. At what value of x does f have a discontinuity due to a vertical asymptote? And give a reason for your answer. So let's take a look. That would be at the x that makes the denominator 0, but does not cancel out. It's a non-removable discontinuity, and notice that occurs at x equals -2. If I had more room on the paper, I would give more reasoning, but I abbreviated it here. Have a great evening.